let me introduce you to Aram and Stanislav. Aram has over 20 years of technical background that includes distributed, highly scalable, and redundant systems design and support. And Stanislav has an extensive experience in developing and running self-service platforms on cloud-native applications. Let's give them a round of applause. Thank you, guys. It's a pleasure having you. The stage is all yours. Don't forget to ask questions on Slido.
Check, check. Yeah, works. Hey, guys. So, good afternoon again. After lunch coma, hope not so much influence you, so we can start. But before starting, let's first shoot a question. How many of you have pets? Nice. So the next one would be, how many of you used Zooplus as a pet supply? Well, see, half. So this means you know now after this talk to which customers use, and we will tell you more about what is happening behind the zoo gates. But first thing first, as you know, we will quickly introduce ourselves again. So my name is Aram, and I'm leading platform team in Zooplus.
My name is Stanislav, and I'm principal platform engineer at Zooplus.
Well, actually, the presentation should be happening with also Christian Posta, who is global field CTO and Solo.io, but unfortunately, he wasn't able to fly in from US, so we'll conduct this together. And instead of Christian, here we have another Christian who is also working in Solo.io. So in case you have some questions, feel free also to approach him. So Zooplus, right? So Zooplus is European online pet supply company, founded in 1999 and currently shipping to 30 countries in Europe and UK. So you can imagine, right, what is special for Zooplus. Zooplus is truly tech company from heart of it, which I could say is one of the key competitive advantage in the market. Already 10 years ago, we started DevOps transformation and journey to a culture. We defined clear shared responsibility models and empowered our development to own the full stack from product development, deployment, monitoring, and retirement. But to decouple the monolith, by that time, 10 years ago, we needed some container orchestrator, right? And guess what was it? Any guesses? No. It was Mesos. By that time, Kubernetes was just a baby, and Mesos was something we could deploy in production. Of course, with adding some additional stuff, accomplishing with new software and surroundings, but still, we started the journey with Mesos by that time. But after our developers migrated the monolith to the Mesos, which we ended up with 1,500 products or microservices in the end, 4 years ago, we decided to go forward. And based on all lessons learned, based on all requirements, we started to design our new Kubernetes ecosystem and environment. But before we dive into details for the Kubernetes, I would like to start with outlining our sizes so you get better ideas why certain decisions are made and one in favor over another. Our primary cloud is AWS, and we are having there about 1,400 virtual machines. We're using about 70 services from AWS. If we speak about Kubernetes, we have 40 clusters and about 20,000 containers. This all is running with approximately 4,500 deployments Kubernetes, which is inside of the 500 namespaces. For the observability part, we are shipping about 32,000 log lines per second, which in the end comes to 1.7 terabyte data per day. Let's dive in a bit about AWS infrastructure. First of all, we decided in the beginning that we should first really go with AWS best practices, and based on well-architecture recommendations, separate our resources into multiple AWS accounts. The benefits are security and fine-grained access control, risk and blast radius reduction, clear responsibility mapping, and ownership for each account, product, or whatever your isolation level is good. Data isolation and protection, of course, and cost management. So we can optimize and assign cost per product, team, departments, or division, whatever we need. And maintainability, of course. By separating resources into different accounts, based on product, the cloud environment becomes organized. This is logical separations make it easier to maintain resources in accounts, reduce the risk of failures, which usually can occur when you put everything in just one account, right? Yeah, in the end, you get simplified operations and troubleshooting per team and increased efficiency of housekeeping. Additionally, we had to decide about AWS network concept. So we were considering different models for the VPC and networking, but we want to present here main three network models we were considering. So first one was free shared VPC model. The second one was one VPC per product. And the third one was shared VPC by organization unit with one subnet per tier. So three-tier model, and organization unit could be like any division, let's say, team. Usually it is product development area, logically separated, for instance, the team or department which is developing shop, the department which is developing financial for payment system, logistics, etc., etc. So if we speak about these models a bit in details, so first of all, model with free shared VPC is, so we should put one big VPC with all production services, one big VPC with development services, and in the middle, we need one shared VPC where we put all central services like Bitbucket, Artifactory, so both environment, production, and development have access to deploy code or to push the code or to get the images and code, yeah? So this is actually a low-cost solution with low complexity. It's really good fit for small, sometimes medium companies. Nevertheless, with this schema, there is certain limitation. It is not possible to set firewall rules or security groups based on serial ranges. One VPC is always a big blast radius, right? And the architectures have some limitations in terms of AWS VPC peering. Then we decided to also look on a second model, which would be one VPC per each product. And with product is not a big product, but just a small logical separation. So in our case, we would be ended up with 500 VPCs. Of course, the advantages here that each product is independent in their own VPC, more control over the traffic, yeah, and lower blast radius, the probably lowest unit of the blast radius we have. But the cost would be really high. So only one connection to transit gateway with one AZ costs $130, which means if you use 3 AZs, it will be ended up with 390. And if we have 500 products or 500 VPCs, then it will be ended up with 200K per month. Well, for this model, we had to go with one central Kubernetes cluster, actually. Otherwise, peering connections and doing the whole security and routing would be a really nightmare. That is why we started to think about another model. And another model, in the end, we came up is one shared VPC per organization unit. As I told, organization unit is division, department, or product development center, where every organization unit contains many products. Like you can see here, one organization unit contains different products, which every product sits in a different AWS account. And then we are grouping them based on OUs. So here what we have, group logic per each product, keeping the main traffic locally, because actually the main organizational unit traffic flows inside one VPC. Also reducing quite a blast radius. Yeah, of course it's not full, but not so impactful for everything. And additionally, we are splitting them with a three-tier network. So we have public subnet, we have private subnet here too, and we have data tier, which is like for the mainly storing the data in databases. Yeah. So this is also clear isolation of the data. Well, on the other hand, it is still not so easy to implement, and traffic filtering still have some complexity, but not complex as the previous model. Still, between the organization units, still peering requires between organizational unit, but it's not so many as 500 VPCs. With the organization unit is still blast radius, but much smaller with 1 VPC, and complex to implement, in this case, a bit with one central cluster. So when our cloud team was designing and discussing with us these old schemas, they told, guys, we want to go with this one. What do you think about going with a multi-cluster? And we replied, well, actually, we're also thinking to go with a multi-cluster. Well, this is heavily reduce the potential impact and risk with the blast radius, and we're thinking this is the right model to go. Well, this is actually how we decided to go with multi-cluster. We opted for multi-cluster approach based on our strategic needs and long-term goals. Nevertheless, it is not always valid for all use cases and very depends on company resources and sizes. With multi-cluster, you get distributed workloads across several clusters, reducing the risk of system-wide failure and ensuring continuous service. High security isolation, that means security and compliance needs are met, protected sensitive data and application. The architecture can be quickly scaled in response to market changes, whether it's growing or shrinking. It is always, it's a low having detailed budget and resource for every department, as I told, and division, team, or whatever you prefer to have the budgeting done. Yeah, use cases, as I told, large enterprise companies or companies with high compliance security requirements. Comparing to the simple single cluster solution, if you go there, then it is really simple, low cost, and lower complexity. Well, actually, our shift to multi-cluster architecture boosted our resilience, security, and scalability, equipping us to handle current challenges and future growth. The decision comes with a piece of more complexity, management comparing to the one cluster, but still, for our size company, we decided this is the right choice. So in the next slides, Stanislav will present how we manage our multi-cluster environment, migration journey, challenges, and solution, so you take something more for you today. Thanks.
Yep, thank you, Aram. I will continue. So once the decision was made to start the Kubernetes migration initiative, we started to look on all major Kubernetes distributions. And long story short, as you can see on the screen, the winner for us was KOps for a few reasons. So at the time of the evaluation, it just fitted best to our requirements and helped us to avoid the vendor lock. Coming from completely self-deployed and self-managed Mesos, we wanted to have a similar level of control and transparency, and this is what KOps provides. And yeah, the maintenance efforts are quite low, so even after very recent discussions, we still couldn't justify to migrate to EKS or any other managed solution. So the clusters were up and running. And after initial trainings and onboarding for developer teams, we were waiting for the first migration wave to start. But how to manage resources, how to ensure teams do not override each other, how to ensure there is no wasted resources. So to reduce the overhead and management complexity, we opted for soft multi-tenancy model, which means the development teams are isolated in Kubernetes namespaces using native airbag permissions, but share some common resources like monitoring stack and some Kubernetes operators that we use. The implementation is done via a single Git repository, where all cluster-wide or platform-related objects are defined, such as namespaces, airbag permissions itself, persistent volumes, resource quotas, and some standard config maps. 3 pairs of eyes principle is ensured because of the pull request-based interaction between development teams and platform team. So development team creates the pull request, where they create or modify existing objects. Then responsible architects review it if the configuration is valid from business perspective. and platform team rolls out changes after the technical review. The repository structure is quite simple. All objects that we deploy to clusters are templated with Helm chart in the charts folder. Developer team normally interacts only with the config folder, where all the values files are stored and separated per cluster. Every commit is built on Jenkins, and configs are validated using various scripts in the bin folder. And after changes are rolled out, developers' teams gain view, edit, or admin permissions in according namespaces. All cluster-wide objects, such as persistent volumes, are created and rolled out during the merge and are ready to claim in according namespaces. So now we have clusters. We have namespaces for tenants isolation, and probably even have already some services running in these namespaces. But how to manage access to the services running in the namespaces? How to expose these services to the outside of the cluster? And we opted for Istio to eventually outsource the platform-related logic from application business logic for the following set of the features that Istio provides. So having it allows, with minimal integration efforts, allows you to get features like mutual TLS for achieving zero trust environment. You can offload authentication, authorization, introduce circuit breakers, retries, and timeouts, simplify tracing integration, get out-of-the-box rich traffic-related metrics, and access logs. How it works? Here is the diagram to briefly overview the architecture of Istio. So the data plane is composed from a set of intelligent envoy proxies that are deployed as sidecars, which means just another container in your pod. But these proxies are special. They intercept all network communications completely and managed based on the configuration that is coming from the control plane. And this configuration is separated to some central configuration coming from the platform team, and of course some individual per app configuration coming from multiple development teams. So yeah, the other tools that we started to use after we migrated are Argo workflows, because we have some cron jobs that have dependencies on each other, and this tool just allows you to run them in chain. External DNS to manage Route 53 records. Cilium is our CNI of choice. We are using it in the most basic way because, as previously was shown, Istio manages the rest. Metrics, Open Policy Agent ensures our constraints are met, such as you cannot claim volume you did not create. The pods must have labels and so on and so forth. Metric and alerting are accomplished with Prometheus and Thanos, which is a huge topic by itself. Unfortunately, we're not going to dive deep into it today. Airbag Manager from Fairwinds helps us to manage the airbag permissions easier for our multiple tenants. Velero is used for backup and restore the cluster state. Recently, we have introduced external secrets operator to outsource the interaction with AWS Secrets Manager, and Kiada to have the advanced autoscaling possibilities based on CloudWatch metrics or Prometheus metrics. Few other tools that we use, but I failed to find any logos, are Kube Downscaler, amazing tool that allows you to scale down your development environment completely during the weekends or during the nights, up to you. That saves quite a lot of money, I would say. Vertical pod autoscaler to scale some applications that cannot be scaled horizontally, and some standard things like cluster autoscaler, Amazon load balancer controller, and IRSA. Important part is that all these services are provided to our tenants as a self-service. So Argo workflows is already in the cluster. Just create your workflows or cron workflows. Prometheus already runs. Just set the annotation on pods so it knows where to scrape your metrics and create some rules for Prometheus alerting if you need them, and so on and so forth. But how to make usage of all these services easier for developers. So although the possibility of doing everything yourself is present in our setup, starting from getting your own Amazon account and possibly even run another Kubernetes clusters on your own if you want to. But what we found that most of our users are actually not interested in that at all. They want to write the business logic code and not Kubernetes manifests or Helm charts. So after the research, with help of our colleagues, we came up with abstracted Helm charts that represent the standard application types in Zoo+. So mostly we have API services, various queue processors, and cron jobs. And in the end, this was boiled down to two main charts, the ZP app and ZP cron job app. The only task for development teams to use it is to fill in their Helm values with Docker image, labels, resources, and health props. So here is the minimal values on the screen, and as you can see, they're really minimal. So this, hopefully this helps them to live a bit easier. And additionally, this approach allows us to control which Kubernetes API versions are used in our templates and updated according to our cluster updates. The templates of the main ZP app chart, they reflect all the services that are present in the cluster and require explicit configuration to use them. So for example, to enable the Prometheus monitoring again, based on application metrics, the developer must configure the endpoint for scraping and write some alert rules in according values section. And actually, pretty much everything can be done using values in this chart because it's abstracted. And even if some fields of some of the objects are not templated directly, there are functions written in the Helm charts that allow you to override any field, even though it was not designed initially for templating. So yeah, there it is. This is the bird's eye overview of our setup. Of course, there are many more details, but we are limited on time. And yeah, of course, it was not always the pleasant trip. We had our share of challenges and issues, and I'm going to present some of them. So when you run Kubernetes on Amazon and you do multi-cluster service mesh, the lesson that we learned that the basic issues can ramp up really quick and cause the outage in the places where you would expect it last. So we were still on old kubedns when a bigger part of the applications migrated to Kubernetes from Mesos. And at some point, we realized that the DNS queries start to randomly fail. And the reason was the DNS floods that we created by ourselves. And this is coming from Istio architecture. As I previously said, the proxy intercepts all traffic. This includes the DNS queries, but the DNS queries are handled differently. The Istio proxy resolves every other service from the catalog, like all the known services, on itself, and then it sleeps for TTL and repeats. So when you have 40 clusters and all of them are interconnected with each other, it means all these applications start to resolve each other, because in network load balancer, you get the host name instead of IP address. And for us, it meant we get about 1 million of junk DNS queries per minute, in addition to normal DNS query rate. So the solution was to switch to core DNS with the node local DNS and assign the static IP addresses to the load balancers that we use. With that, we could disable the resolution, and basically, from there on, it's running just fine. So like the old meme says, it's not DNS. There is no way it's DNS. It was DNS. The migration continued, and eventually we found the worrying trend. The more applications we have in mesh, the bigger each sidecar proxy memory footprint grows. And basically, this was the second time the default visibility beat us. So although the DNS flood was already stopped, every pod still had the configuration about every other pod in the mesh. So the best metaphor I found to illustrate it is the city, where everyone has a yellow pages book with the names and numbers of all citizens, and the new version of book is released every time when a citizen moves in or move out, but nobody really needs the full book. So using some of the glue mesh features, we were able to reduce the default visibility to the namespace level, and basically since then the footprint stopped to grow and was quite some reduced. Yeah, so another big challenge we faced was Ingress Gateway's zero downtime restarts. So the voluntary restarts can happen because of the autoscaling or because of the rolling update of the cluster. And the issue comes from the fact that Amazon Network Load Balancer is not Kubernetes aware, and on the opposite hand, cluster, autoscaler, and COPS are not load balancer aware. This means in a default setup, the node is stopped while it's being deregistered from the load balancer. And that means you get unhappy customers because some of your requests fail. Luckily from us, starting from cluster autoscaler version 126, they introduced the node delete delay after taint option, and COPS already had post-drain delay for rolling updates of the nodes. So after checking with our colleagues the request times, we set the registration period to 30 seconds, and the delays are set to 1 minute to have the overlap, which means the node is being terminated after it's already stopped receiving traffic. And since then, Istio is doing pretty well. Yeah, and yeah, another major milestone for us is to replace the custom in-house built gateway with Istio configuration. As you may know, the routing in Istio happens based on the virtual services and service entries. And this works great in a single cluster setup. But as soon as you have multi-cluster, somebody must manage this cross-cluster in-mesh communications. In Istio terms, it means that for every remote service, there must be a service entry in your local cluster, and this service entry must be dynamically updated according to remote cluster changes. And this is, again, where glue mesh helps us. It generates these service entries for each remote services and keeps them updated. And together with another great feature of route delegation, it allows us to create the root route in a designated cluster and delegate the subpath of the call to remote cluster. So as you can see here on the screen, depending on which path you go, you always be routed to a proper place. So the routing is composed dynamically based on all routes configured across all clusters. And with that approach, the development teams have complete freedom to split or to change the routing accordingly in their assigned subpaths, completely independently from the platform team. So yeah, what is glue mesh, which I mentioned a couple of times but didn't say anything about it at all. So with all the goodies that Istio brings, it's still massive and complex to get all the benefits. So this is where glue mesh jumps in. To briefly summarize it, glue mesh immensely simplifies multi-cluster service mesh management. It abstracts and enriches most of the base Istio features and automates certificate management, making zero trust easily achieved in a multi-cluster environments. So nevertheless, Istio logo is a yacht. Glue mesh actually doesn't ride it. It carries it on its shoulder. And yeah, basically this is where we're at. But of course, there is always a space for improvement. So I'm handing over back to Aram to present our next ideas.
Thanks, Sten. Hello? Yeah, works. Thanks. Thanks, Sten. So, yeah, making the platform and infrastructure scalable and secure is a good thing, right? Making our life of software engineering and making easy for migration of 1,000 applications just easily from old infrastructure to new is great achievement. But this is not the end of the story. Yeah, during the whole process of migration, and even now, we're constantly getting the feedback from our development team. We're constantly speaking with them to understand the needs and improve their experience. At some point, we concluded that we need to go to the full standardization and abstraction to change the working model and making life of engineering teams easier. But not only. With higher degree of standardization, we're planning to tackle the following challenges we see now. Decreasing learning curve, especially for the new joiners, which require quite efforts to get to this whole technology and abstractions we have. Frankly, finding a such senior engineer who knows the whole technology and can just jump in and bring the value is also quite hard. Decreasing time to market, by delivering new applications, taking quite efforts, since software development actually taking care for the whole process, so they need to take care for CI/CD, writing their manifests, deploying their applications, ensuring their monitoring and alerts for their whole software, etc. And keeping all this up to date, also quite an effort, because we're constantly upgrading our Kubernetes clusters. There is different software versions upgraded, and there is new features coming, so development team always should kind of have some efforts or some capacity reserve in their sprints to catch it up and keep it all up to date and implement new features. But not only that, as a central team, we are always in Q&A with our development team. So we have about 450 developers, and then constantly coming with us with some questions. We are constantly doing some trainings for new joiners or for all developers for presenting new features and improvements. So, and what was actually our surprise when we've been in KubeCon this year in Paris? So not only we are speaking and thinking about the problem, but all community talks was related actually to the internal development platform, a concept and a solution to standardize tooling and make effectively and abstracted the work of the development team. In the end, to build the ecosystem and not wildness. Well, speaking about Istio here, I would love to also talk about the next step for the Istio ambient mesh. This May 13 have been introduced as an new Istio ambient mod, and it has announced the production ready. This is actually the community built it around the Istio, and one of the leading contributors of the community is also Solo.io. So, Istio ambient mode introduced lightweight sharing layer 4, node proxies, and optional layer 7 if you want, removing the need for the traditional sidecars injected to each microservice. So, in old version, you always put the so you always inject the Istio sidecar in your microservice, just close to it, which require dedicating resources for it. And in current ambient mesh mode, you are just putting one ambient mesh in your virtual machine as a DS, and then you're done. So with a Z tunnel, this drastically reduces overhead of running a mesh by removing the need of potential overhead provisioning memories and CPUs, and in some cases, it reduces the CPU and memory footprint for 90%. Yeah. So this is all, guys. Thank you, all of you here. Thank you, CraftConf, for inviting us and having here, and for listening. And also taking a chance, I want to thank our team who make it possible to create such amazing platform and present it to you, so you take something for you today. So now we have time for questions.
Time for questions, yes. First, let me give you a little bit of Hungary.
This is two or... Yes.
Thank you very much for your talk. We have a little time for questions. The first being, do you have central monitoring for all clusters, or each have their own monitoring?
Well, not easy question, right? You take?
Yeah, yes, I can answer that. I would say it's mixed. So we have some parts centralized, like Elasticsearch stack, which is actually a managed service that we just rely on. Regarding the metrics part, it's the, again, mixture of centralized and distributed, because in every cluster we run the separate Prometheus, but all the Prometheuses are connected to the central Thanos.
Thank you. The next, you mentioned 40 clusters. Are all those prod clusters or dev staging is included also?
No, this is actually, we have like about 20 clusters for production and 20 clusters for development, not including staging and testing. So this is another story, right? But this all setup and all pipelines actually running and provisioning the clusters are the same. So if we go with the release process or how we provision and update our clusters, we actually creating pull requests, making some updates, then testing this all changes on feature clusters first, because we are running like branch per commit. So every branch which we create and making features for testing, then spinning up new cluster, doing the whole test set, ensuring that everything works, and then we roll this cluster, roll these changes to the testing cluster to ensure also the rest of the tests and integrations. And then we provision this all changes to development clusters. So development clusters, we were letting them to run a few days to get a feedback from development teams if everything is good, and then we go for production.
Thank you. The next, is Istio hard to operate at scale? Is Istio hard to operate at scale?
Hard to operate at scale?
Yeah.
Well, of course, it is quite different managing Istio in one cluster and managing Istio in multi-cluster environment. But as soon as you go from one cluster to two cluster, at least in our setup, we ensure that the rest our workflows are streamlined, so then there is not much complexity. But of course, that is why one of the reasons we go with a glue mesh to relieve this complexity and make the abstraction level where the glue mesh helps a lot to manage this layer.
Thank you. The next, are you considering adding tracing as well?
Of course we do, it's just didn't have time yet. We have the initiative in our backlog, and I don't know, maybe this year?
Yeah, definitely this year, because I discussed it with one of the colleagues in our team, and we decided we definitely need to go to this step this year. This is kind of one of the final steps in finishing the whole ecosystem for the Kubernetes. Why we were not so fast? Because it's actually not so complex on our side. But it's acquired also efforts, maybe not so quiet, but comparing to if you take, like, you have thousands of applications, then development teams also need to ensure to put the correct headers and ensure that the headers transmitted to another backend microservice and another microservice. So this whole chaining is happening, so tracing is also like available. Yeah, that's why we were delaying it. But yeah.
All right, we have time for one more question. Why was AKS service not an option?
AKS?
That's what's written here,
okay,
AKS.
That's from Azure Kubernetes Service, I guess. Because we don't run almost anything in Azure, I would say, so we didn't even look too much into it.
But you're probably also interested, not AKS or EKS, right? So it doesn't matter something in cloud which might easy you the provisioning. So initially, when we started to look on the different version of provisioners, let's say, we first of all, EKS wasn't prominent at that time, and we spoke with AWS folks, ensuring what is their roadmap, etc. On the one hand, at that point, we weren't able to start with AKS. On the other hand, we wanted to have the control on every tiny things which we can do with the COPS, on every minor configuration or changes. Because, of course, you have the AWS support, you have everything which they can help you in case you have major incident. But, you know, putting the whole production, the business, like all things under the hands of another guys managing that could be a bit risky. Of course, it is option for some of them, and especially now when it is quite mature to go with EKS or AKS, right? Especially if you don't feel comfortable to deep dive in, and find the tiny things to fix and improve. But if you're feeling confident, then yeah, that was our choice back then. And now we were considering, and actually this year we're like thinking, okay, does it make sense to shift to EKS? And actually we didn't found any argument which will prove the effort of migration, and probably maybe some issues after that to go to EKS.
All right, thank you. There's another question here saying, why did you stick with COPS instead of EKS? Now EKS, but I think that's kind of answered. Yeah. Yes. And have you considered using Argo CD?
We tried multiple times to find a fit in our organization. The thing is that our team is not responsible for running the Zoo Plus applications. We run the platform, and the approach in company is you build it, you run it, which means for us, we just couldn't find justification to switch from Jenkins. And again, or not again, yeah, huge shout out to our colleagues from Jenkins, because in Zoo Plus, I think the Jenkins setup is most beautiful I ever saw, enriched with so much libraries, constantly updated. So yeah, again, for developer teams, what I saw, like the minimal pipeline to build and actually deploy your application in production is only like 20 lines of code, because everything is also abstracted there.
Yeah.
Okay. We are out of time for questions. We still have 2 questions if you're up to it. But for those of you who want to go for the break starts now and finishes at 55. Don't forget to give the speakers their feedback and use Slido and Pine for communicating with the organization. Now, let's have these 2 last questions, right? Can you tell us a bit more about standardization? What was it successful at the end?
Yeah, standardization, like at a level we can do the standardization, I would say it is maximum level which we can get ever. So developers, if not speaking about Jenkins, which there is also like a lot of standardization, and guys can just deploy with defining DSL libraries, like specifying Kubernetes tags in a library. But on the other hand, as Stanislav showed, there is like really small, tiny YAML, which developers just need to fill in and ship their application, deploy their application to Kubernetes. And then automatically it will appear for you. Whether it's shipping the logs or metrics or whatever, you just need to add some annotations or some tags, and that's it. So this is the level of standardization and abstraction we have currently. But as I told, the next level will be to develop internal development platform, which will abstract out everything from developers, where they go to the self-platform and then adding some values and then provisioning their code. This is not only helping to reduce development time, but also helping to automate under the hood things. So all updates, all changes will not be require anymore any developer interactions.
All right.
Including provisioning of infrastructure as well, because in our team's development, they are also provisioning infrastructure. So they're spinning up a cloud, AWS account if needed, provisioning their infrastructure based on different modules, which we have also created, and then provisioning applications. So this all will go under the IDP in the end.
I am very happy that you keep sending us questions, but please don't, because we are out of time, all right? So
we can follow up to the questions if we
absolutely, yeah, that's what I want to encourage. That after the talk, you also go after the speakers and talk to them. But just not to leave any stone unturned. I'm not taking any more questions, okay? A challenge for you. I have 2 more questions that maybe you can answer in one go. Have you had a look at Cluster API to manage your clusters instead of using COPS? And what were the advantages of COPS?
That's the tricky question. I think the cluster API, we were only briefly looking maybe last year, but I'm not really proficient at the moment to answer it. Not entirely sure if it actually fits the multi-account Amazon model with three-tier networking that we do, if it's possible to use it this way. Yeah, and advantages of KOps, basically it's free, it's open source, it provides you at the same time good level of control what you're doing and transparency, and you basically have access to all the things. And if something is unclear, it's again open source. You can go to their GitHub, read the code, figure out why something is not working as it should.
Yeah, also not creating the vendor lock-in, and also supporting not only AWS but also IKS. And we were thinking also to go on-prem by that time when we were making decisions. So we wanted to have one interface or one code base to provision everything from the same view or same way, right?
Thank you very much. That was amazing for my Hungarians and for Roberto and Marie.